The night sky and the lure of space have always pulled on the human imagination. But exploration did not really take place until the mid-1900s. But then it happened fast.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Early space exploration was both competitive and collaborative, but the media really focused on the competition that was these heightened political tensions and an extension of the Cold War.
Reaction was one of astonishment and concern.
On Sputnik 1, the Soviet space satellite.
Research in space improved life on Earth from the very beginning, and today, the International Space Station is a symbol of global collaboration.
The amount of money spent on the space program is worth every penny. I think there are things we get from the space program that are valuable to our life on Earth.
I'm Karina.
And I'm Myrna James. It's time to go behind the wings.
In this episode, we're going to explore the question, how did human spaceflight start, and how is it affecting us today? To start, we headed to NASA's Center for Human Flight, Johnson Space Center, to talk with NASA historian Jennifer Rothnazal. How did Johnson Space Center first get started?
In 1958, NASA was created.
This is my first opportunity to greet you as Deputy Administrator of the National Aeronautics and Space Administration.
It was created as a response to the launch of Sputnik.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket.
The first orbiting satellite around the globe. And Congress was very interested in establishing an organization to put a human being into space. And there was a group established called the Space Task Group. It was established about a month after NASA came into being. Its purpose really was to put a man into space. It was a manned satellite program. It became known as Project Mercury.
Project Mercury is the name given to the nation's manned orbital spaceflight program.
They were based out of the Langley Research Center, but that group formed the nucleus of what would become the Manned Spacecraft Center here in Houston. Once Kennedy gave his speech in May of 1961 that we were going to land a man on the moon by the end of the decade and return him safely, they realized they needed an actual facility, an actual center just for human spaceflight. Before that time, human spaceflight was seen sort of as a passing fad, a fancy. The deputy director for NASA at that time likened it to shooting a lady out of a cannon. And so it was sort of fortuitous that Kennedy proclaimed that we were going to achieve this amazing goal by the end of the decade.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
And so they started looking around at other locations all across the country, and Houston was one of those locations. So it was built essentially to get us to that final end date of landing a man on the moon by 1969. The individual who was in charge of the Space Task Group at the time heard that announcement and wondered, my God, how are we going to accomplish all of this? And he had to figure out how they were going to make all of this work in a very short time, in about 9 years. So that really was, a huge challenge. But NASA had been actually studying how are we going to get to the moon prior to this. It just, increased the pace. NASA was trying to figure that out well before President Kennedy made this announcement on the floor of Congress.
Now it is time to take longer strides. Time for a great new American enterprise. Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
It was definitely a proxy war for the Cold War. If you look at the Kennedy administration, they had the Cuban Missile Crisis. They also had, some other missteps early on in the administration, and this was an opportunity for him to take something and get a win. How could he beat the Soviet Union? And this was something that they realized we might be on more even ground with the Soviet Union, sending a man to the moon and returning him at the end of the decade.
Lands Giant Leap, Apollo 11 lands crew on moon. The first Wright brothers flight was in 1903, and then it was only 66 years later when Neil Armstrong walked on the moon. in 1969.
A lot happened in those 66 years. The NACA, or the National Advisory Committee for Aeronautics, had been around since 1915, and people had already been thinking about human spaceflight.
These astronauts had to learn everything, every aspect of going to space, from rocket propulsion to orbital mechanics to what happens to the human body when they go to space, right?
So how did the first astronauts prepare to go to space, somewhere where no one had been before?
Astronauts train a lot, and so do folks in flight control. There's the saying that you train as you fly as you train. In those early Mercury flights, they did a lot of training because they weren't exactly sure what to expect. They put them through centrifuge rides up in Pennsylvania. They put them on the KC-135, which is a weightless aircraft. They did a lot of simulations of their missions, what they were going to be doing in orbit. Same thing with Gemini and Apollo. They were working through all of those missions and working through all of the requirements for their flight. They didn't just get into the capsule and go up in orbit and kind of see how things worked. There was a lot going on behind the scenes before anyone ever went up.
NASA has spent a lot of time throughout its history of going into remote environments and what they call analog environments. So to put astronauts or scientists in extreme environments all over the world. We know the ones, for example, like Antarctica is a classic. Back in the days of Gemini, Mercury, and Apollo, there was an interest in going into remote jungle areas. So the Air Force had a training program in tropical survival down in Panama. And so NASA contracted with the Air Force to bring the astronauts like Neil Armstrong, Buzz Aldrin, Michael Collins into that survival program. They went into the territory of a tribe down there called the Embera, which was and still is a remote jungle area.
And so they went down to Panama at the Albrook Air Force Base. And they were working with the Choco Indians, so they were natives of that area. This was a really great cross-cultural exchange for astronauts and also for the natives in Panama. The idea basically behind Tropic Survival School was, first of all, to learn how to survive if, God forbid, your capsule came down in a jungle environment. How would you handle that?
We're in Panama, where it all started. The first NASA astronauts to walk on the moon were trained here for wilderness survival by the indigenous people, just in case.
We've driven about an hour outside of Panama City, and we're about to get into a dugout canoe with a motor, and that's the only way to get to his village. We'll interview Chief Zarco there.
Ahí está bien.
Ahora vamos al museo.
Chief Zarco, tell me about your grandfather.
Estos son mi abuelo, la esposa y varias hijas de ellos. Dice también en verano que tocó la luna. Mi abuelo aquí muy joven, sí, muy joven. Y bueno, aquí tenemos otro que estaba entrenando. Nosotros acá le decimos balsa, cómo se amarra, cómo cortar. Entonces él le está enseñando. Lo que él enseñaba es a los 11,000 soldados y también a los astronautas.
People who were being trained to go to the moon and go into space acknowledged what they could learn from you and from your culture. Chief Zarco, what were some of the things that the astronauts learned here?
Cuando ellos subían a la luna, cuando ellos caían en la Tierra, ellos ya sabían lo que mi abuelo, lo que enseñaron cuando estuvieron en la Tierra, cómo sobrevivir, qué comer cuando ellos ya caminaban, cómo ellos podían tomar agua, fruta, qué fruta puede comer, qué fruta no puede comer. También tenemos como las plantas medicinales, entonces ya ellos sabían cómo hacer, en qué parte están, porque nosotros también utilizamos lo que es el sol, en qué parte estamos, entonces así sobrevivir.
Why is this area such an ideal place to train astronauts?
Donde nosotros estamos, el bosque es cerrado. Hay muchos árboles grandes. También mi abuelo nos explicaba, cuando fueron a Vietnam, en ese tiempo, la guerra, en Vietnam es parecido a este lugar. Por eso que los americanos llegaron a este lugar. Entonces toda esa experiencia que mi abuelo le dio, ya ellos sabían, pero también compartiendo con los astronautas. Siempre en nuestra cultura, nosotros cuando uno muere, un envenenado, decimos, bueno, el envenenado ya se fue a la luna. Por eso que también cuando hablaron de la luna, viene la persona, bueno, voy a enseñar. Nuestro abuelo decía, bueno, nosotros vamos a enseñar todo para que también ellos conozcan.
You know, they had a lot of cross-cultural interaction with the Choco Indians, worked very closely with the chief, Antonio Zarco, and you know, encouraged them to get to know the folks as part of their training so that they would feel comfortable. And when they came back, they did a debriefing and talked about, well, what did you learn? And you know, they learned that the jungle isn't as scary as they thought it was. The most important thing I think that they walked away with was the fact that it was important to have this optimistic point of view when you went on a mission, that you weren't going to die if you landed in the jungle or desert, because they did desert survival training. You know, it was important to do the training, but to have optimism that you were going to make it out okay.
Some of the astronauts who trained in Panama actually were the ones who walked on the moon.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
The Earth, as it appears from the moon, is a very small and fragile object. And when you think about it, that's not an inaccurate description. Certainly a lot of the things that we do down here can affect the balance in a very fragile way. The greenhouse effect we're noticing today, for example, the changes between a healthy atmosphere and an unhealthy atmosphere are very subtle, very, very fragile, and you sort of get that feeling when you look at the Earth from a great distance.
Seeing the Earth from space can cause a significant psychological impact called the overview effect. To learn more, we spoke with cultural anthropologist Dr. Dina Weibel.
Dina, it's so great to speak with you today. What is the overview effect?
So the overview effect is a term that was actually coined by a journalist, Frank White, who is also a researcher. When people go into space for the first time and look from their spacecraft to the Earth, the awareness that it's actually a planet, suddenly the borders are not real anymore. You see that they're imaginary. You see that everything is interconnected. You see the Earth as much more fragile. And a lot of astronauts have had this experience where it was like a sudden realization, something that caused them to rethink what it meant to live on a planet, rethink things like environmental awareness. Some astronauts have become really, really strongly focused on getting information out about global climate change and other things we need to do to protect the planet.
Steve Lindsay, I'm so excited to speak with you today, and I almost don't know where to start. You've had such an illustrious, amazing career.
I applied and was fortunate enough to get selected in 1995 to the NASA astronaut office as a pilot astronaut. So I spent 16 years at NASA, and while I was there, I was fortunate enough or blessed to fly 5 space shuttle missions, 2 as pilot, 3 as a commander.
That's amazing.
Yeah, I was very fortunate. My final flight was actually the final flight of Discovery. The trip in a space shuttle.
Go for main engine start.
Being on a launch pad to orbit is 8.5 minutes long.
We have main engine start.
Most 8.5 minutes of intensity you'll ever experience.
2, 1, and the final liftoff of Discovery. a tribute to the dedication, hard work, and pride of America's space shuttle team.
Discovery's 3 main engines are burning fuel at a rate that would drain an average swimming pool in about 25 seconds. The engines, combined with the solid rocket boosters, produce more than 7 million pounds of thrust. Standing by for separation of the twin solid rocket boosters, Discovery now traveling 2,695 miles an hour.
I'm picturing this extremely fast speed that you're going. And it makes me think of the overview effect. So what was that like? Did that happen for you?
I first saw the Earth on my first flight. We were, during ascent, we were probably 50, 60 miles high, doing about, I don't know, Mach 12 or so during ascent. So the rockets are firing, and we actually did this, what's called a roll to heads up, to shift from ground stations for communications to satellite communications during ascent. And I was in the pilot seat, of course, pretty busy. But when we did the rolled underneath, and I got my first view of the Earth. When you see Earth from up there, it does change perspective. I think it changes your perspective on how small the planet is. It changes almost everybody's perspective from an environmental standpoint.
Yeah, I remember one of the first times I looked out the window from space and I said to one of my crewmates, I said, what's that thin film over the surface? What is that? They go, oh, that's the atmosphere. Almost looks like a contact lens over somebody's eye, how thin and fragile it is compared to the size of the planet, which is kind of scary looking because it's the most important thing to our survival is our atmosphere. I think makes you more kind of in tune with environmental causes. I remember the rainforest in South America looked different on my first flight than it did on my last 17 years later. And then when you look at the planet, you don't see political borders. During the daytime, you do at night a little bit. Countries sometimes use different kind of light bulbs, so it's easy to tell. I'm on the International Space Station, but we're really all on a spaceship traveling through space called Planet Earth, and we're all part of the same team.
I know that you were on the International Space Station for basically a year. How did that come about?
Yeah, I was there for nearly a year. We launched in March of 2015, landed in March of 2016. It's one of the greatest successes of the International Space Station program is that you can have two countries that, historically can be at, not on the most friendly basis, unfortunately. You can work cooperatively on something that's probably the most challenging thing we do and demonstrate that we can work peacefully together as a team, and space is a perfect place to do that. And for us, our relationships as crew members, we have to rely on each other for, friendship, for help with our work, and literally at times for each other's lives.
Out of that competitive atmosphere that defined early space exploration came a whole new vision for collaboration. And then the International Space Station, and so many countries are involved.
The International Space Station, it's truly that, international. You have 258 astronauts that have been there from 20 different countries. And then when it comes to the countries involved in the ISS, I mean, this is going to test my geography more than anything, but we've got the US, we've got this big one.
Right, Russia here.
Russia.
Enormous.
We had Canada. Canada's up there.
We have Japan right here.
Japan, yep.
JAXA is very involved with space activities.
And then, you have the European Space Agency, which is going to make up a lot of the countries. Belgium, Denmark, France, Germany, Italy, the Netherlands, Norway, Spain, Sweden, Switzerland, and the UK.
The International Space Station is just that. It's truly international. It's almost like in space, where borders don't exist.
The idea was that this would be a good way for NASA to get experience working on an International Space Station. That was the goal, to have our own space station. We had our first space station, Skylab, but this was going to be a little different. So this was an opportunity for astronauts to get some experience working on board a space station, kind of this building block for NASA. The international aspect of space station has been so vitally important. That's probably the most important legacy that space station will have. Many of the pieces of hardware, for instance, never met on the ground. The first time they met was up in space. And so just working together, I think it's so vitally important. We may not be able to do it on the ground, but in space we've been able to do it so successfully.
Hi, this is Steve Lindsay, commander of the Space Shuttle Discovery. Welcome.
You know, when you look at the space station and the international partnership and 16 nations up there working together all the time, that all gets blurred, and we're generally speaking one team up there. If you'd have told me when I was a pilot in the Cold War that within 10 years I'd be flying with Russians, I would have told you were crazy. But that changed.
Right now the plan is to deorbit the space station around 2030, right? And eventually you're gonna have to do that. I mean, things age, they age in space. You got on a spacewalk on the space station, it's surprising just how beat up it is outside. And the sun is just brutal. The changes of temperatures of, plus or minus 270 degrees. Thing gets hit on the outside. There's a lot of holes on the outside. Fortunately, so far those holes haven't penetrated the pressurized volume, but there is a lot of damage to this. So eventually you're going to have to put it in the Pacific Ocean.
One of the most important things that came from that experience was the twin studies, because you have an identical twin brother who's also an astronaut.
Yeah, because my brother and I were identical twins. We're genetically very, very similar, almost like, 99.9% genetically similar, that they felt like that they could get some good science data.
So the NASA twin study, the idea was born to try and get more genetic information and more molecular information and other types from people in space for longer periods of time. That's a little bit complicated to do, so what they thought was if we're going to use very small number of people, that they should be twins. That would allow us the ability to study one twin in space and the other twin on Earth. Doing that would allow us to better understand the differences that weren't related to genetics, right? Because they should have a fairly similar genetic profile.
For something to be statistically significant, you need a lot of samples.
Right.
And this is kind of a sample of one. Having said that, it's also a longitudinal study, so you can get statistically significant data by studying the same thing over a long period of time, meaning Mark and I.
So the goal was then to study them for 1 year, and Scott Kelly was the astronaut who was in space. And so both of the Kelly brothers gave enormous amount of time, willingness, blood samples, every kind of tissue we could get, psychological testing, physiologic testing, over that entire year period. And so at the time it was really the longest and most comprehensive scientific study that had been done to that point.
So that became part of the science program, and it got the most attention, more attention than the other science, which was actually probably more important, but just didn't have that kind of like cachet, human interest cachet that a story about two twin brothers doing a science experiment on the space station had.
Give us a few nuggets of the results of the twin studies.
Well, there are a lot of experiments, and I didn't give these experiments any more attention or less attention than I did everything else that we were doing. To the researchers, all of them, their science is the most important. And during the course of that year, we had 400 different experiments going on the year I was on the space station.
That's incredible.
Yeah, so this was, I don't know, it was probably 10 or 15 different studies. Some of them were on human cognition, like how does your brain change over the course of being in space from your ability to perform certain tasks and functions. What we would do is, I would collect data, or mostly it was like science samples, but there were tests that I would do, and then my brother would do the same ones on the ground. And I'll tell you what, you got to give him credit, because he didn't even work for NASA. I think they were going to pay him, but it was like so little that he said, don't bother. I don't want to deal with the tax headache from being paid, it's just really small amount.
So why is space exploration so important?
I think it's important for a number of reasons. We are, genetically speaking, I think explorers, right? If we didn't have that gene, we would still be living in a cave somewhere. We have this desire to see what's, over the horizon, what's over the ocean, what's in outer space, and what it gives to our society, to our economy, to our national security is worth every penny.
If you look at history, that's what human beings do. We've always explored, well before Christopher Columbus. you know, well before the Vikings. That's just something that human beings do, and I think that's just a continuation and an extension of what we've done in the past and will continue to do. And it's extremely important, it's extremely vital, beneficial to the American public, to the globe.
As space exploration transitioned to becoming more collaborative, it set the stage for how it can benefit life right here on Earth. But it's not just about going outwards, going to the moon. It's also about looking back at Earth. What can we learn about our own blue planet?
Looking back at the Earth from space gives us a whole new perspective on our planet.